Here we have another fresh subtopic under line integral. Now we have line integral in space. What does this thing tells us? Whenever you are dealing with a line integral in space, that means I'm no longer having, let's say we don't have x and ordinary y alone. What if you now have a 3D plane, like having a function in terms of x, in y, and in z? You have x, y, z. So the first thing I have to just consider here is very, very straightforward. Um, I can decide to put it in this form, that is in vector equation. But we believe that if I have an integral along a smooth curve, okay, which is in terms of three different variables, it's in space now. That means it's not just two coordinates, it's not just two variables. Now you're having three different variables. That's f of x, y, z at the same time, and then we now have a ds. So now take note of this. This ds now is going to be expressed in another form, whereby we introduce a vector format, like saying, no, I started with fr. I stated something before. I said we have two formulas for line integral, the one in vector form. But let's just put it this way. Suppose you have r in terms of t to be equals to a function of x in terms of t. Okay, you can express you can easily see an expression of x in terms of t from that question. So it's a vector that's x of t of I in that direction. They can also have y of t. We also have y of t in j direction, and at the same time we have z in terms of t in k direction. So if you want to see questions like this, I will show you. Let's just start with this. So whenever you see a question that comes in this format, like giving you in vector form, or you can easily see x of t in that question, they can tell you that x is equals to t sine, let's say sine 2t. So whenever you see something like this, that means think of line integral in space. And you also be given y also. Y can be t squared plus 4. And z will also be given. So just think of this formula, please. So when you have this kind of presentation, whereby you have this parametric equation will be given to you. You know, it's in terms of t. This is a parametric equation of x, y, and z. So if this is a parametric equation, then what happens? How will you deal with that kind of line integral? So then the formula this formula here becomes whatever you have here. It will be integral of the function given to you. Substitute x of t wherever you see x. This thing here, put this thing here inside whatever is given to you here, wherever you see x, and then substitute your y of t, and then substitute your z of t. You might not understand what I'm trying to say until I try an example. So then after getting this result, you have to multiply it by uh, taking the square root, or you just try to um, write it in terms of half, but I prefer to write square root. Take the square root, and you know I said you have x to be equal to this. First thing you have to do is to differentiate this x with respect to t. Whatever you get, square it. Are you listening? So then you add it with, take y also, the parametric equation given to you for y, differentiate it with respect to t, and then you square the result. And at the same time, take the z, the parametric equation for z given to you, let's say t cube minus 1. Differentiate that z with respect to t, square the value. So try to evaluate this thing, break it down to get a final answer. That's just what we call line integral in space. So let's take a question. Um, let's consider this question. Example. So let's call this example 6. I think that's the next one. So I have a question there which says that evaluate the integral. Let's say we have, can I form question? Okay, I think I still remember this. Evaluate this integral along a smooth curve C, whereby we have y sine z. Yes, I think that was what is in the material. Then we have ds. Now this time around, you know there's no x. It's not necessarily. This shows that you already have a line integral in space. Now you're now having three different variables, y and z. So you have to solve this. But now you have ds. You know what ds is representing? This ds is this expression that we have here, the whole of this square root, and this becomes this. Okay, take note of that. And then in that same question, we are being told that where c is the circular function given by the equation Now I said, how will you know when to make use of line integral in space? Whenever you see this parametric equation, okay? So now we are not given an equation, but it was not stated that it is parametric equation. But from what is given, you will know that it is parametric. Now we have x, we are given x to be equals to cos t in that question, comma. Then we also given y to be equals to sine t. And then finally, z is now given to us as z is given to us as t. So you should know what to do from here. What do I need? X is cos t, y is sin t, and z is t. So by formula, this is very, very direct. If you see this kind of question, just solve it in a very clear way. It's very, very easy to solve. And then, okay, this is what I have. I have y sin z is yes, but we believe that the formula, you must remember the formula always. And I don't think there's nothing wrong. I don't think there's nothing wrong with the formula. You can easily cram that. Just take the integral of the function you have, put x of t inside wherever you see x, put y of t wherever you see y, and put z of t wherever you see z. That's all. Then take the square root of the derivative of x with respect to t, square the result, derivative of y with respect to t, square the result, and derivative of z with respect to t, square the result. And then from here, I believe you should know what to do. What is this f of x of t? That's f of, what's x of t given to us? X of t is given to us as cos t, comma, what's y of t? This is y of t, okay? Y of t is sin t, and z of t is what? Is t. Do you understand that? And then after this, we have to take the square root of dx dt. I can easily do that without even making it elsewhere or finding a jotter to do that. Dx dt is very direct. Dx dt, differentiate this sin t, that's minus, sorry, differentiate cos t with respect to t, that's minus sin t. Square the result. Plus, what's dy dt? Differentiate this one, that's what? Cos t. When you differentiate sin t, that will give us cos t. Square the result. When you differentiate z, the z dt, that's 1 in this case. So you square it. So are you following? And then after having this result, so you should know what this thing implies. You know, when you have f of 2, 3, that means wherever you see x, put 2. And wherever you see y, put 3. But here in this case, we're having x to be cos t, y is sin t, and z is what? T. Now, go back to the question. This is my f of x, y, z. Happy now? And then y sin z is what is given to us. What's y? Y is what? Sin t. Since x is not given, so just forget about this. It's not given. So there is no x in the question. We only have y sin z. And what is y? Y is sin t. In this case, y is sin. I mean, this is x, this is y, and this is z. Do you get that? So this y is sin t. That means y will be replaced as sin t. Okay? This sin t. And at the same time, sine of what's z? Z is what? Z is what? It's t. Do you see that? So z is t. So I have sine t times sine t. That's sine squared t. Okay? Then followed by square root of, when you square this negative sine t, I will have sine squared t, plus when you square cos t, that's cos squared t, then plus 1 square is 1. So trivially, this is going to give us, sorry, okay, let's do it here. Then I should have integral is equals to, I hope you are following. So this thing is not something that's really hard. And then we should have sine t times sine t, that's sine square t square root of. So I saw something here. Sine square t plus cos square t, that's 1. Sine square s plus cos square s is 1. 1 plus 1, that's 2. So I have square root of 2 left. Do you understand that? Then after that, I have I to be equals to, let's take the square root of 2. It's a constant. Let's take it outside. So I have square root of 2 integrate sine square t. And then if you want to integrate sine square t, you should know what to do from there. But here in this case, I want to integrate sine square t. But we need something in this case. We need the lower limit and the upper limit. So do I know that for now? So let's try to check. So something might be left out in the question. So I have just checked now. The question says, given this equation now, then another thing is given, like something was stated where it was stated that where 0 is less than or equal to t is less than is equals to 2 pi. So it is given, the range for t is given in the question. Okay. So